Welcome, ladies and gentlemen. Let's go ahead and get started on our conversions practice day. And so firstly, what is a radian? What is a radian? Well, we've seen in the past that a radian is an angle measure, right? The size of a radian is directly connected to the radius of the circle. And so a radian then is a bridge between length and spin. That is straight line motion and angular motion. And we'll use that with our conversions later. But for now, an angle that measures 1 radian intercepts an arc that measures 1 radius length. So an angle of 1 radian inside intercepts an arc length of exactly 1 radius. And we can see here our radian and radius connection. Jacques.
So is the radian, is that the actual like degree measure, or is that the or is that like the 1 radius wrapped around the circle?
It's the actual angle measure. It's measured in radians, not degrees, but it's the actual angle measure. So a radian is the size of an angle, right? The radius is a length. Radian is an angle size. Yes, good question. All right, so let's go ahead and make a picture for that. So if we wanted to draw an angle that measured 1 radian, we'd simply take this radius length, r, and we'd wrap it around the outside of my circle so that that arc length was the same as that radius length in black, and then connect it back to the center of my circle. This angle that we just made in the center, that angle in green, measures 1 radian, right? It measures 1 radian. Does that make sense? Awesome. So a radian is a connection between radius length, right? Between radius length and angle size. All right. How many radians are in 1 full circle of rotation, and why? Right, so how many radians are in 1 full circle of rotation? Well, we saw in our conversion and our radian activity 2 that there are 2 pi radians in 1 full circle. Why are there 2 pi radians in 1 full circle of spin? Well, because the radian is the connection between radius length. How many radius lengths are there in 1 full circumference? Well, there's 2 pi radius lengths in 1 full circumference, and that's why there's 2 pi radians in 1 full rotation of a circle. So since there are 2 pi radius lengths in 1 full circumference of a circle, there's 2 pi radians in 1 full circle of spin. Awesome. And lastly, how many degrees correspond to how many revolutions correspond to how many radians? Go ahead and share with the class when I call on you. Get ready. So what's our relationship here? Samantha?
363.
Awesome. Everybody take a look at number 3. Raise your hand if you have the same as Samantha. 360 degrees corresponds to 1 revolution, is equivalent to 2 pi radians. Nice job, you guys, and thank you for sharing. Great. What questions do you have on 1 through 3? Let's use then our identities from number 3 to go ahead and do some conversion practice. So here we go. 5/12 revolutions to exact radians. On the quiz, some people lost 1 point out of 2 because you didn't go to exact radians. And so we want to remind you, right, how you can get that exact out of your calculator. You can hold off on entering the pi. Let's see what that would look like. So 5/12 revolutions. We'll start with the fraction. It's already a fraction. We want to make sure we include our label there because that'll drive the problem. And now we'll multiply by our identity. Our identity whose sole purpose is to get rid of the label we don't want, in this case revolutions, and move to the label we do want, in this case radians. And so get ready because I'm going to call on you. In how many revolutions, there's how many radians. What's my identity there? What's my identity there? Aaron?
2 pi radians and 1 revolution.
Good, thank you. There's 2 pi radians corresponds to 1 revolution, right? 2 pi radians corresponds to 1 revolution. Now we can enter this in my calculator. If I hold off, right, on entering the pi in there, then I can go ahead and change this back into a fraction. I can do this non-calculator by reducing the 2 over 12 as well, but I want to make sure that you're comfortable using the math frac on the calculator. So yes, we can do this easily without a calculator. I just want to practice 5 times 2 divided by 12. I'm going to leave out the pi so that when I do my math frac, it'll change it back into a fraction and I get 5/6. Now I'll put the pi back in on top and I get 5 pi over 6. And so I get 5 pi over 6 radians. Go ahead and raise your hand if you already had that, please. So who already had that? 5 pi over 6 radians? Awesome. So 5 pi over 6 radians corresponds exactly to 5/12 of a revolution. Let's do 285 degrees to exact radians again. So once again, we'll begin with my given 285 degrees. We'll make that a fraction by putting it over 1 and then multiply by an identity, whose sole purpose is getting rid of the label I don't want, in this case degrees, and moving to the thing I do want, in this case radians. We know that in 360 degrees, there are 2 pi radians of spin. We can cancel our degrees, and again, I'm going to go ahead and leave out the pi in my calculator and then put it back in on top because I want exact. So let's try that and see what it looks like. 285 times 2 divided by 360. Enter. Math. Frac. And I get 19/12. 19/12, is that right? And I'll put the pi back in on top, so I get 19 pi over 12. And the label would be radians. Raise your hand if you already got that. So we already get the 19 pi over 12. Good job with the exact, you guys. That's awesome. Way to go. And we are one left then. Let's do 11 pi over 3 radians to degrees. So we'll start with our original. In this case, 11 pi over 3 is already a fraction, label with radians. Now multiply by a conversion fraction. We want to get rid of radians. We want to go to degrees. We know that 360 degrees corresponds to 2 pi radians. And we also want to make sure that my calculator tells me the correct answer to what I'm asking. So for that, I'm going to put parentheses around that bottom so that I'm multiplying by 3 times 2 pi all on the bottom, not just dividing by 3, right? And then multiplying by 2 pi on top. So I'm going to tell my calculator I want to divide by all that stuff on the bottom. Let's try. 11 pi times 360 divided by left paren to open up the denominator, 3 times 2 pi, right paren to close. Right paren to close the denominator, and let's see how it goes. Voila! I get 660 degrees. We'll take a screenshot of this so we have it for all those calculations. And go ahead and raise your hand if you already had that. Did anybody get all the way to 660 degrees? Awesome work, you guys. Great job. What kinds of questions do you have about today's Bellwork? Okay, so let me make that a little bit bigger. And now we'll go ahead and take care of our day 11 graphing worksheet check. I'm going to pause the recording now so we can take a look at our assignment. Okay, ladies and gentlemen, let's take a look at our schedule then. And so, because of the Aspire late start days, today we're going to work on our day 12 conversions practice worksheet first. You'll have time to finish that with lots left over, and you're going to use that time then to work on your trigonometry review problems from day 13. Next class for 8A students will be very short given the Aspire late start schedule, so you won't have much time to work on the review, and that's why we're pushing that day 13 assignment into today, day 12, all right? Our unit test we're setting up for is Monday, the 16th of May, so you want to make sure that you're setting aside time. Sign up to come and see me on contact time, right? Come and see me and ask questions as you work and prepare. Remember, Unit 8 is the biggest unit that we look at trigonometry all year long, and so you want to make sure you're ready to work and prepare. That's going to be the last test going in Infinite Campus for your semester coursework prior to the final exam. Our probability unit, Unit 9, is going to be just kind of a preview. It's not going to have now a test or quiz in that unit itself. things will be assessed from probability. There'll be a couple questions on the final exam that deal with the concepts from day 1 and day 2 in our probability unit, but you're not going to have a separate test or quiz. That makes it all the more important that you use your time wisely, make sure that your Unit 8 score that rounds out our Infinite Campus semester coursework in the computer is a good one, okay? Questions about what the rest of the day is going to look like? Awesome. Then I'm going to go ahead and pause the recording now and save it and put it on Moodle.